You ever look at a totally normal, flat photo and wonder if a computer could see it the way we do? Not just as pixels, but understanding the space, the depth. It really sounds like something out of science fiction. But a new AI model, and get this, it's called Depth Anything, is making that a reality. It's pretty wild. Let's dig into how it all works.
Okay, just take a look at this. Up top, you've got your standard 2D pictures, right? A living room, a party, a city skyline. But what's below them, that's what the AI is actually seeing. It's a rich, detailed depth map. See the bright yellow areas? That's stuff that's super close to you. And the dark purple and black? That's way off in the distance. It has literally taken a flat image and figured out the 3D space inside it. It's kind of mind-blowing. But how on earth is that even possible?
I mean, seriously, how does it know that the chair is in front of the fireplace or that one building is miles behind another one, all from a single picture? That is the big question, the fundamental challenge, and that's exactly what we're going to unpack. So first, we've got to get our heads around the main problem. Researchers call it the monocular challenge. It's a fancy way of saying you're trying to see in 3D with just one eye, or in this case, from one single flat image.
The official name for this whole field is monocular depth estimation, or MDE for short. And this isn't some new thing. It's a classic problem in computer vision. It's got huge implications for everything from robotics to self-driving cars. The basic goal is simple. Figure out how far away every single pixel in a photo is. Sounds easy enough, but actually doing it, well, that's incredibly hard.
For years, the main way to teach an AI how to do this was, let's be honest, kind of a brute force method. You had to feed it mountains of what's called labeled data. These are images that come with an answer key, basically, an exact map of the real-world depth, usually captured with super expensive LiDAR sensors. And creating this answer key, well, that created a huge problem.
And this brings us right to the core issue, the big bottleneck, the labeled data problem. You see, you could have the smartest algorithm in the universe, but if you can't give it enough of the right data to learn from, you're just stuck.
Now, the researchers behind Depth Anything, they started with what seems like a ton of data, right? 1.5 million of these really high-quality, pre-labeled images. This was the good stuff, the gold standard that other models were built on. But even with that much, they were hitting a wall.
So why was that a problem? Well, for one, creating this data is super slow and costs a fortune. But even more importantly, think about it. 1.5 million pictures, as many as that is, can't possibly capture the crazy variety of the real world. Every possible object, every lighting condition, every weird angle. No way. This limited data was holding everything back. So the researchers had a pretty radical idea.
They thought, okay, instead of trying to scrape together more of this perfect, expensive data, what if we just went the other way? What if we used a truly colossal amount of cheap, imperfect data? What if we just used random pictures from the internet with no depth information at all? And that is exactly what they did. Get this. They ballooned their dataset with over 62 million regular, unlabeled photos. We're talking random pictures from all over, stuff that's incredibly easy and cheap to get. This was a massive shift in scale, jumping from 1.5 million special images to a grand total of over 63 million.
And the researchers said it best themselves. Their big aha moment was realizing the incredible power of just scaling up with massive amounts of cheap, diverse, unlabeled images. So, okay, that's the big idea. But how in the world do you make all that random data useful? This right here is the secret sauce. This is where the real cleverness comes in. They came up with a system to turn that gigantic, messy pile of photos into the AI's biggest strength. They used what's called a teacher-student model. It's a pretty cool idea. First, they trained a teacher AI on that original high-quality 1.5 million labeled dataset. This teacher got pretty smart, but not perfect. Then they unleashed the teacher on all 62 million unlabeled photos and had it make its best guess on the depth for every single one. These guesses are called pseudo-labels. And finally, they trained a brand new student model on everything, the good original data and the massive pile of new pseudo-labeled data. But there was a catch.
At first, it didn't work. The student model just wasn't getting any better than the teacher. It was basically just learning how to copy the teacher's answers, mistakes and all. It wasn't gaining any real deep understanding from all those new images.
So they decided to give the student much harder homework. Instead of just showing it a nice clean image and the teacher's guess, they started messing with the images they showed the student. They applied what they call strong perturbations. Think of it like changing all the colors, blurring things, even cutting and pasting parts of other images on top. This forced the student AI to stop being lazy. It couldn't just rely on simple clues like color or texture anymore. It had to learn the deep, fundamental geometry of a scene to pass the test. It had to get smarter.
So, the big question is, did this tough love teaching strategy actually work? Did the harder homework pay off? Oh yeah. Let's look at the results.
The proof is right here in the numbers. This chart shows the error rate on a standard data set for self-driving cars. Remember, lower is better. The old champ, a model called Midas, had an error of about 12.7%. Depth Anything just crushes that, dropping it all the way down to 7.6%. Now that is not a small tweak, that is a massive leap forward, almost a 40% reduction in error. And you can literally see the difference. Just look at this cafe scene. The older models, they kind of get the general idea, but it's all a bit fuzzy, a bit blurry. Now look at the bottom row. That's Depth Anything. It's not even close. The lines between the chairs, the table, the umbrella, everything is so much sharper, so much more defined. It just understands the scene on another level.
And here's another fantastic example. This scene is super tricky. You've got graffiti, a fence, moving water. The other models just get totally confused by it. But look at the bottom image again. Depth Anything nails it. It sees the flat wall, the individual rails on the fence, and it even understands the texture of the rocks behind the waterfall. That training on a massive, diverse dataset really paid off here.
So, okay, a new AI is better at seeing in 3D. That's cool, but why does this really matter? Well, this breakthrough is way bigger than just one research paper. It has some really profound implications for how machines are going to see and interact with our world. Just think about it for a sec. For self-driving cars, this could mean way better 3D vision from a simple camera, making them much safer. For robotics, it means a robot that can actually navigate a cluttered room without bumping into everything. In AR and VR, this allows digital things to feel like they're really in the real world with you. And for anyone who's a creator, this opens the door to turning literally any photo into a 3D model for games, movies, you name it.
And that's really the big takeaway here. The huge bottleneck of needing expensive, perfectly labeled data has basically been smashed. By using this clever teacher-student trick with a massive sea of normal photos, these researchers have built something that can see depth in pretty much any picture you throw at it. Which leaves us with one last, really exciting question to think about. If any photo can instantly become a detailed 3D map, what are we going to create next?